I'm James Johnston, Manager of Training and Support at Microsurvey Software. I'm happy to tell you in this little video about some of the digital terrain modeling capabilities of Microsurvey embeddedCAD or in CAD. The first drawing that I have open allows me to show you how you can create a surface and visualize it using a number of different methods. What we've got here is the whole 16 green from a golf course, and it was surveyed, and points and line work was generated, and they've been used to create a surface representing that. And so I'm visualizing it using this tin, and what I can do is I can hide that tin so we can see some of the details in the background. And why don't I change my current layer first? Here we go. Okay, and so there you can see where all of the survey data was represented and all of the break lines that were used as well. It's nice to point out that with Microsurvey CAD, the entities that you need to create a surface are very simple, just 3D, polyline, and line, and so forth. And so once the surface was created, then a digital terrain model is saved. And with Microsurvey, you can plot the surface and you can represent it using a tin or using contours or a variety of other options. But the surface itself ultimately is actually saved as a separate format, a QSB format. And so here we're able to see two surfaces that I already have loaded up. And the advantage of saving them as a separate file is it's very simple to either trade surfaces between jobs so that you can make a surface in a simple project and then just add it to a more cluttered one later on. Or you can also save surfaces that represent different times. A lot of our clients have projects where they come out and they just redo a survey every month, and they want to be able to do a comparison of one surface to another. So they just save the surface itself and they don't worry about the rest of the drawing. Makes it very easy to compare. You can also save surfaces in land XML format, which is handy for sending them out to the field for staking and so forth. I will use an isolate tool here just so that we can have a look at the contours that were created. So here you can see where contours were plotted, and the contours are smoothed, and I can just show you how we could also add a contour label. So I'll go over to modeling, go in and label the contour, where I'll tell it I want to plot some 1 foot high labels, and I would like to trim the contour to make room for the text. And then you can just zoom in here and you can pick the contour that you want to label, and it picks the elevation off the or out of the entity and trims it back. So here we can see multiple different contours. And of course you can also see as I zoom in here that we've used a feature that allows me to alternately color my contours. So I'm coloring every fifth contour is red. And you'll also notice that I've smoothed the contours, or I didn't need to make that one. I've smoothed the contours using the smooth command, and that way your contours aren't quite as chunky as they look when you're drawing contours directly on the tin. So there's what we can do with generally creating surfaces and visualizing surfaces. This is a very commonly used aspect of embeddedCAD. Okay, and then let's get on to volumetrics. This is another area that's very important to our clients, and I'll show you two examples of types of volumetric features that are in Microsurvey's embeddedCAD. And I'll point out that between the two methods we can resolve pretty well 95% of all volumetric problems, with the exception of things like tunnels and overhanging surfaces. Those get more complicated. In this example, we would use what I call a surface volume method. And so this is your typical stockpile volume situation where I'm using a tin to represent a surface that was created from the survey data that represents the top of a stockpile. And then if I turn this upside down a little bit, you can see that there's a polyline I'll just zoom in on it here. There's a polyline that follows right here, and it's a 3D polyline, and it's been used to create the bottom surface, and it'll represent the original ground before the stockpile was added. I'll give you a quick rundown of how you could do a volume report. I'll just open up the command line so we can see what's going to appear there. On MS Modeling, if we activate surface volume, here's the usual interface. And so usually what we do is we pick, or you subtract new from old in order to get negative cuts and positive numbers to represent fill. And so I'll just pick my new and I pick my old, and you'll see there's a number of other options you can choose here. I'll just give you a quick overview. When I pick on OK, then I get a volumetrics report right down here in the command line. There's my net, there's my negative, there's my positive. And so that is the most common surface volume method. Sometimes I'll show you a slightly more complex type of volume problem where I'll turn things on the side just so that you can understand, so that you can visualize what we're doing. The situation might be that we want to get a volume between two surfaces, the upper and the lower there, but back to the top here, we want to be able to limit in the XY where that volume is being computed from. So we'd actually like the volume to be inside of that green polyline that you see there. And even to make it easier to visualize, I'll turn it on its side again, and I will add some thickness to that polyline just to make it project through the two surfaces. And I'll change the visual style to make it easier to see. So now when we're using the area volume, what we'd actually be wanting to do is compute a volume that is contained within this shape here and between that bottom and top surface. Okay, and I'll give you kind of a quick overview of what that would look like. So let me take that thickness out of there again. It's not even required in order to do this kind of a volumetrics report. And then, so the process for an area volume method, I'll open this up. This looks exactly the same as before. Now I'm just going to pick the two surfaces from the previous example. We won't be completing this operation. And then once I've picked my two surfaces, that would be the red and the green surface that you see there. When I pick on OK, I am prompted down here to select an object. In this case, I'd be selecting that 2D polyline. And then it'll give you a volumetrics report that is according to the image that I showed you. So there you go. That's the area volume method. And like I said, 95% of all volumetrics problems can be resolved between those two methods. Finally, I'll just give you a little bit of an overview on the design capabilities within embeddedCAD. So here is an example from a training file, in fact, where, so to help you understand what we're doing, I will just freeze the layer that has that tin in it, because this is the final result of what I'm going to talk about. And so in this training example, the students are given some contours, and they use it to generate an original ground surface. And over here you can see that they've been given the dimensions of a holding tank design that we'd like to have sit right on the ground. And so we've given a dimension for a walkway around the top, and then we're going to use a 3D offset function to also project 6 feet by 6 feet and to create the bottom of that holding tank. And so as I zoom in here, you can see the result of that operation. So you can already see on the contours, you can see where the 3D polys that are going to be used to create this surface are all set up. And then what students do is they use over on the design ribbon, there's a function here called auto site design. When you open that up, so it allows you to specify which you'd like your cut slopes and your fill slopes to be. It allows you to choose options for whether or not you want it to project the cut and fill slopes up or down, and you can do both, in fact. And then here, this is one special feature right here. I ask it to include the nested polylines, and so that'll mean that it'll pay attention to those 3D polys that we put inside of this outside shape here. And then you tell it which surface to consider the original ground surface, and you can tell it down here what new surface to create. And I will cancel that, because then all that I would need to do to complete the operation is choose this 3D poly, and it'll apply those surfaces. It'll look at the 3D polys that are inside, and it will generate a new surface. And that new surface is represented here by this tin, the design tin. So you can see where you've got the cut and the fill surfaces. I'll try and get my mouse off to the side so you can see it better. You can see where the cut surface is, and just up at the top there's actually a little bit of a fill surface, and you can see where the interior, the tank part of this design has been created. And if I just look at the bottom here, you can actually see where the tank part projects into the original ground. And so once you've got that designed, of course, you can export that as a land XML for construction, or you can do a volume computation with it, or all kinds of other things. Or, well, you can plot contours on it and draw it up and get it built. And I won't have anything to show you here, but you'll also notice on the design ribbon that embeddedCAD has everything that you'd need to create a simple road alignment. So you can design a horizontal alignment, you can design a vertical profile, you can design a template, and then much the same way you saw me do with this auto site design, you can slide that template down your alignment and generate a new design surface. Then you can do volumetrics. You can output a land XML of the alignment, the vertical profile, and even the design surface. You can also, use microsurvey to plot labels. You can design surfaces with it, and you can, you're not going to design highways, but you can do an awful lot of just basic subdivision, road, and infrastructure design using embeddedCAD. So there you go. That was a whirlwind tour of what you could do with embeddedCAD in terms of digital terrain model, and I've only scratched the surface. If you have any further questions about it, please continue the discussion with your microsurvey contact and learn more about it. Thanks for your time watching me.